Okay, so what are complex numbers? So as a definition, complex numbers are any number written in the form a plus bi, where a is going to be the real part. This is going to be the real part of the complex number. This is the real part. And then the bi is going to be the imaginary part. The imaginary part. So a complex number has these two components to it. Now, if you look at this Venn diagram, you'll see that the real numbers that you guys have worked with your whole lives is a subset of the complex numbers. So we have the real numbers here, the imaginary numbers will be here, and then the overall number set here is the complex numbers that has a real part and an imaginary part. So how does the set of complex numbers compare to the set of real numbers and imaginary numbers? First question, do all complex numbers include an imaginary part? Well, if you look at the Venn diagram, all complex numbers do have a real part and an imaginary part. Remember, they have the form a plus bi. And then this bi part is the imaginary part. So yes, all complex numbers do have an imaginary part. So here we'd say yes. Next question says, are all real numbers complex numbers? And guys, again, if you use the Venn diagram as kind of a tool here, notice how the real numbers, which are represented by this circle in the Venn diagram, do you see how all these values are going to be inside of the complex numbers? So here again, you would say yes, all real numbers are complex numbers because they are a subset. They are a subset of the complex numbers. So again, if you look at this Venn diagram, every real number that we have falls within this circle. Well, this entire circle is underneath the complex numbers. So everything in here is also going to be a complex number. With that being said, look, the goal for today really is just to see that these exist and that we can identify the parts of these numbers and then learn to work with them within our notes here in quadratics. So then let's try two examples. For examples D through G, we want to just identify the real part and the imaginary part of a complex number. For example, in example D, if I see 9 plus 5i, the real part is going to be the 9. That's the real part. I'll just use R for real. And then the imaginary part, in this case, is going to be the 5i. So for example D, 9 plus 5i is a complex number. The real part is the 9 number, and the imaginary is the 5i. If I look at example E, notice how in this example, I just see a negative 7i. So in this case, notice how you don't have the real part visible? That's because I can write this as 0 minus 7i. So in this case, my real part is going to be 0. This is my real part. And then the imaginary part in this complex number will be the negative 7i. So again, the first goal right now is just to simply identify the components or the parts of these complex numbers. There's a real part and an imaginary part.